is such a pleasure and an honor to be here, and I greatly appreciated the hospitality of every university that we've gone to, and just I really appreciate the beauty of your culture and just the richness of your heritage. And I'm also incredibly grateful about all of the young minds, the people that may be future scientists, future government leaders, future pastors that want to present the truth about design in nature. And it really will help shape your culture. And today I'll be talking about design related to our universe. And I'll begin by talking about the issue that our universe had a beginning, and then I'll talk about the fine-tuning of our universe, and I'll conclude by talking about the evidence of design in our planet, our sun, and our moon. Now, one of the interesting facts about this debate about design in nature is it goes back a long way. In fact, as far back as about 500 BC, you have Greek philosophers like Democritus who debated other philosophers like Plato, Aristotle, and Socrates. And Democritus was what was called a materialist. And a materialist, as Dr. Luskin mentioned, is a person who believes everything is the product of atoms interacting according to natural laws, and then those atoms and those natural laws, chance and time, can explain everything we see in our universe. Everything from our sun to our planet to life itself. And they debated people like Plato and Aristotle who believed that matter in and of itself did not have the ability to self-organize into everything we see today, but there was a mind behind our universe, or minds, and the mind envisioned blueprints for life, and then that mind shaped matter to conform to those blueprints. In other words, they believed in design. And what's happened is in Western civilization, the pendulum swang all the way to the materialist view of the world, that the idea of design was purged from the academic realm, from biology, from physics, to everything we see in life. But what's happened is over the last century, and particularly over the last several decades, evidence has come in that's forced the pendulum to swing back towards design. And I'll share with you some of that evidence. And one of it comes from the field of cosmology, which is the study of our universe and the beginning of our universe. Because what happened is Democritus and the materialists of ancient times believed that the universe was eternal. And because it was eternal, you had all the time you needed for random interactions of matter to produce everything that we see. And that was carried on. And and what happens at the turn of the century, the 19th to the 20th century, is many other scientists believed that the universe was eternal for the same reason. Because they believed it needed lots of time for chance and random processes to produce everything we see in the world. Also, they liked the idea that the universe did not have a beginning, because if the universe was always here, then you wouldn't need to explain where it came from. You would need to resort to a designer. In fact, if you've ever heard of Carl Sagan and the famous series called Cosmos, Carl Sagan was an atheist, and he said the universe is all that ever was, all that is, and all that ever will be. It's sort of a doxology, religious type language to say that the universe is absolute and all that there ever was. That all changed, though, around the early 1900s, because there was a famous scientist who I'm sure you've heard of named Albert Einstein. And Albert Einstein came up with what's called the general theory of relativity. And it's expressed by this equation. This is the famous field equation. And what it describes is how matter and space interact. Because in classical physics, like with Newton, gravity is a force. So the Earth pulls objects towards it because of the force of gravity. But from Einstein's perspective, what happened is if you have a mass, the mass actually bends space, or technically space-time, for those of you that are in physics. And the bending of space space is why an object will change velocity when influenced by some large massive body. What happens is the bending of space causes space to redirect matter in a different trajectory. The famous saying is that matter tells space how to bend, and the bending of space tells matter how to move. What happened was Einstein and others applied his field equations to the entire universe, and that's where you get something like the Friedmann equations, and this describes how the universe will expand or contract. Well, the problem is these equations suggest that the universe was dynamic. It's in motion. It's either expanding or contracting. But Einstein believed the universe was eternal, so the universe should always be the same. So that was a problem. So what he did was he looked at a particular constant in these equations called the cosmological constant, and he set it to a very specific value. And the reason he did that is the cosmological constant describes sort of the energy permeating space, which causes space to expand. It's like a negative force. So what he did was he set the cosmological constant to the precise value to counteract how gravity was causing space to contract. So that's how we got a stable universe. It was highly contrived. Now, what happened is people like Arthur Eddington, who was a famous cosmologist and physicist, he explained how even if you did set the constant to a particular value, it was highly unstable, so that the universe would still expand or contract. In addition, what really sealed the deal was that people discovered, like Hubble, that the universe was expanding. So because the universe was expanding, Einstein's assumption about that constant was false. So Einstein had to eventually accept the idea that the universe had a beginning because the math forces it to be that case. Now this was shocking because what people had to realize was that everything, mass, time, space, and matter had to have a beginning. And then from the beginning, everything developed. Now, Christians differ about when that beginning was. Some argue it was only a few thousand years ago at creation. Others believe it was longer periods of time. But regardless of how old one believes the universe is, what's absolutely clear is that the universe had to begin. Everything. Time, space, matter, and energy. What that means is because nothing can create itself. You don't see Coke cans pop into existence out of nothing. But only something outside of time and space that was infinitely powerful could have created the universe in an explosion of light, which kind of sounds like Genesis. In the beginning, God created the heavens and the earth. In the beginning, God said, let there be light. And again, you don't have to be Christian or Muslim or some other religion to accept this truth, but it's undeniable that the universe had a beginning, which is very consistent with my beliefs. Now, scientists try to work around the beginning. You have things like what's called the steady-state universe, where the universe was always expanding, and you had matter being created in between galaxies. But what happened was that theory, by people like Fred Hoyle, collapsed because of a lot of the empirical evidence. Some also believe the universe expanded and contracted, and bounced, then expanded and contracted. But because of entropy, we know that can't be the case. Because every bounce, the universe would take longer and longer to expand and contract because it was becoming more disordered. That means as you go back in time, eventually the speed of the bounces becomes infinite, which again points to a cosmic beginning. But one of the most interesting ways to get around the beginning was with Stephen Hawking, who is a very, very famous physicist. And he said that so long as the universe had a beginning, we could suppose it had a creator. Again, he recognizes the connection between creator and the beginning. But if the universe is really completely self-contained, having no boundary or edge. It would have neither beginning nor end. It would simply be. What place then for a creator? So what he was arguing is that the universe really didn't have a beginning. Well, what's amazing is I and others have looked at the research, the technical papers that Hawking was appealing to make that claim. And it's all based on what's called quantum cosmology. And quantum cosmology deals with the universe when it's really, really small. And when the universe is small, you're dealing with quantum mechanics, which is the science of the small, but also you have to deal with general relativity, which is the science of really massive things. So when he developed quantum cosmology, here's the paper he drew from, and here's the equations from this paper. I apologize if this is causing you trauma, if you don't like mathematics. You can just kind of turn your head away, and I'll tell you when it's safe to look back at the paper. But for those of you that understand quantum cosmology, me and maybe a few others, you'll see an immediate problem. Because what happened is Stephen Hawking and Hartle had to solve this very complex equation. And to solve it, what they did is what's called a Wick rotation. It's a mathematical trick. And it deals with what's called imaginary numbers. Now, an imaginary number simply means you have an I, which is the square root of -1. And that is not real, because any number that you square gives you a positive number. -3 squared gives you 9. So the square root of 9 is 3. So a square root of a negative number is not a real number, it's imaginary. And what he did, what mathematicians do, is they talk about numbers as having a real part which is on the x-axis and an imaginary part which is on a perpendicular axis. So what Hawking did was he replaced time, which is on this axis. Notice how I rotated the axes, so now x is going up. So time normally goes up and down, and what happens is you can create what's called imaginary time, which goes left and right. And imaginary time is just multiplying a variable by I. Now, what happened is when you make this mathematical trick, you start with a universe with a beginning, with a point, but when you go from time to imaginary time, you change the axis, which removes the point by turning it into a bowl. Now, it's mathematical smoke and mirrors, because what he did was he got rid of the beginning of time by removing the time variable and replacing it with another variable that had nothing to do with real time. Now, when you solve the equation, what happens is time reemerges and the beginning of the universe reappears. So it's only in this mathematical trick where he solves the equations that the beginning disappears. So his claim that he removed the beginning of the universe was completely false. It was a trick. It was smoke and mirrors. So that really wasn't fairly honest. But he goes even further. In his book, The Grand Design, he says, because there is a law such as gravity, the universe can and will create itself from nothing. Spontaneous creation is the reason there is something rather than nothing, why the universe exists, why we exist. It is not necessary to invoke God to light the blue torch paper to set the universe going. He has a real God issue. I mean, it's really quite fascinating. Now, there's another physicist named Lawrence Krauss, who's an atheist. He wrote A Universe from Nothing, and he appealed to another cosmologist named Alexander Vilenkin, who also developed a cosmological model based on quantum cosmology, and here's his equations. So what happens is Hawking and Lawrence Krauss, or more technically Alexander Vilenkin, claimed that because of the mathematics, the universe would create itself. But that makes no sense. If any of you studied physics, you would have remembered the equation F equals ma. That's force equals mass times acceleration. So in the case of gravity, you've got a planet, the planet produces a force. If I let go of my pointer, it's going to fall to the ground, acceleration. But if I write F equals MA on a blackboard or a whiteboard, the math doesn't cause a planet to come into existence and a pointer that the planet can then react with. Math doesn't do anything. Math describes what happens when a universe already exists. And again, I looked at the mathematics, both of Hawking and Hartle and of Alexander Blanken. And again, those of you that know quantum mechanics and general relativity will immediately see the problem. The mathematics does not describe a universe coming from nothing. It describes a universe that already exists and then gets bigger. So the claim that a universe came from nothing is not true, because when they use the word nothing, they don't mean nothing, they mean a small universe. More smoke and mirrors. It's kind of like a magician that wants to pull a rabbit out of a hat, but if you look closely, the tail of the rabbit is kind of sticking below the hat before he begins. Now, there's been other attempts to remove the beginning more recently. People like Steinhardt, who came up with another cyclical universe model, which is a universe that expands, it then starts to contract, and then it doesn't completely contract, but it expands again. And what happens is this model only works because it's so contrived. I mean, he has this idea of brains that bounce, and the brains cause the universe to expand and contract. You've got this expansion in the early part of the universe that happens in just the right way and just the right time. So again, the only way this model works is with enormous levels of intelligent design. But even beyond that fact, what happens is this model is subject to what's called the Bohr-Guth-Vilenkin theorem. And the Bohr-Guth-Vilenkin theorem basically dictates that any universe that's expanding on average, like this model in our own universe, must have had a cosmic beginning. So his claim that this model can overcome the beginning does not work. And of course, another example is Roger Penrose, and he's a famous physicist. He has this idea of what's called the cyclic conformal model. The idea is that you have a universe that expands, then all the stars burn out, the black holes disappear, and then you have this crossover event where the dying embers of an ancient universe suddenly become the Big Bang of a new universe. But here again, his model only works because it's so contrived. He imagines what he calls the phantom force. It doesn't do anything until you have this specific crossover event, and then it expands the universe in just the right way to create this cyclical universe. Now the problem with this model, there are many problems. One is it has to be incredibly carefully designed to work, but it has to assume the universe was infinitely large in the infinite past with infinite amounts of energy, which is philosophically problematic. So what we see is that there are no plausible models for the universe that do not have an absolute beginning. It's unavoidable. Now, there's one more attempt to avoid a beginning, and that was by people like Alexander Blanken. And they did imagine that the mathematics actually did cause the universe, but they realized that there's a problem. Hawking said, what puts fire in the equations and makes the universe remember this problem? And Blanken even more thoughtfully said, does this mean that the laws are not mere descriptions of reality and can have an independent existence of their own? In the absence of space-time and matter, what tablets could they be written upon? The laws are expressed in the form of mathematical equations. If the medium of mathematics is the mind, does this mean that the mind should predate the universe? In other words, even if you think about this idea of mathematics explaining our universe, the only place mathematics can exist before the universe existed is in a mind. So it is unavoidable that the beginning of our universe points to a mind. But it gets even more exciting, because what physicists have realized studying physics over the last several decades is that the laws of nature appear to be designed. They're not an accident. Now, just to illustrate that, I want you to imagine that someone gives you a universe starter machine for Christmas. And what this machine does, it has lots of dials and knobs, kind of like a mixer board for a concert. And you control every detail of the universe that you create. Isn't that exciting? So you turn a knob up, it's going to have higher gravity. You feel heavier. When you turn the knob down, it has lighter gravity. You feel lighter. Another knob controls the mass of a quark or a proton. Another knob controls the entropy or disorder of the universe. Another knob controls the expansion. So you can set the universe however you want. So what you do is you set all the dials, you hit the button, and whoo, a universe comes into existence. Well, if you set the dials randomly, there is no chance you would produce a universe that could support life. In almost every universe you created with random parameters, the universe would either be a bunch of black holes or a diffuse soup of gas that would never produce a cell. So again, this is the challenge. And this is realized that, so what happens is to have a universe support life, you must set multiple dials with enormous precision. This is recognized by a physicist named Fred Hoyle, we've mentioned his name before, who was an atheist, but he recognized something very interesting. He realized that for our universe to produce carbon and oxygen in stars in high enough levels to support life, many details have to be carefully set. So for instance, the force that holds electrons and protons together in a nucleus is called the electric force or the electromagnetic force. So on your universe creating machine, you would have to set that dial right to within a few percent. Because if that force were larger by a few percent or weaker by a few percent, life would not exist in our universe. The same with the force called the strong nuclear force, which holds protons and neutrons together. That also has to be set within a few percent. If that percent were a few percent larger or smaller, no life in the universe. So that's really quite remarkable. So that would be like a dial that goes from 1 to 100, that you have to set from something like 32 to 37. So. But an even more extraordinary example is the force of gravity. Because if you imagine all possible values for gravity, that would be reasonable to expect. That would be like from 0 to the strong nuclear force. If you were to set your dial to allow for a universe to support life, that dial would have to be set to 1 part in 10 to the 35. That's a 1 with 35 zeros behind it. Now let's talk about that in terms of precision. Well, how precise is that? Well, have you shoot guns before? I mean, imagine you have a target that's 1 centimeter by a 1 centimeter diameter target. If you would hit that at a kilometer, you are a really good marksman. I mean, 2 kilometers, you're like Jason Bourne or James Bond. You're just really great. But to set the dial for gravity properly would require a precision comparable to hitting that target at the other end of our solar system. That's the precision we need to set gravity in such a way to support life. And even more extreme is the cosmological constant. Again, this is the energy that permeates space that allows space to expand. Now, that constant would have to be set for a life-permitting universe to 1 part in 10 to the 90. That's a 1 with 90 zeros. That would be like hitting a target 1 centimeter in diameter at the other end of our visible universe. It will not happen except by design. And the most extreme example is that of entropy, and that's the disorder of the universe. That had to be set to 1 part in 10 to the 10 to the 123rd power. Now, just to write this number, you have to put a 1 with lots of zeros. In fact, if you put a 0 for every particle in the universe, the visible universe, you still couldn't write that number, it's so small. With unbelievable precision. This is so striking that Fred Hoyle, again, an atheist, said a common sense interpretation of the data suggests that a super intellect has monkeyed with physics as well as with chemistry and cosmology. he was an atheist, he still could not deny the fact that our universe appeared designed by a mind for life. Now, the way people try to get around this problem is with what's called the multiverse. You may have seen Doctor Strange in the Multiverse of Madness. And the idea is that there's not just one universe, but there are many, many universes. And every universe has slightly different physical laws. So we just happen to be lucky that we ended up in a universe that won the lottery. It had the right details for life to exist. Oh, there's a problem with that. Because every model for a multiverse has to also be fine-tuned to allow for it to produce universes in the right way such that one can support life. An example of that would be inflationary cosmology. Now, inflationary cosmology was initially developed to explain certain fine-tuning in the universe. This is the cosmic background radiation, and this is the radiation we experience in every direction in the middle space, and it's remarkably uniform. It's uniform to one part and about 100,000, and that isn't what you'd expect from normal Big Bang models. So they had to explain why that seems so uniform. Also, what happens is a space is flat, meaning that it's not curved inward or outward due to general relativity. And the chance of that happening would be like 1 chance in 10 to the power of 60. So to explain away these issues, they came up with what's called inflationary cosmology. The idea is that very early in the universe expanded very, very fast, and then it stopped expanding, and then just kind of continued according to normal general relativity. So this inflationary period was used to explain away the uniformity of the background radiation in the flatness of space. Now the details don't matter, but this is what matters. Other people said maybe this inflationary cosmology happened for a long period of time, and every universe created that's inflating had different principles, different properties. And that's the way you can explain the fine-tuning. You just let in the right bubble universe that had the right properties. The problem is, one of the architects of inflationary cosmology is Steinhardt, and he wrote an article called Pop Goes the Universe. What he argued, and remember, he's one of the people that developed the theory, is that inflationary cosmology would only work if pretty much every detail were carefully designed for the purpose of creating the universe that supports life. So the odds of an inflationary cosmology model producing life by chance, some have said is like 1 over 10 to the power of several million. That's 1 with like a million zeros. So again, the inflationary cosmology was designed to explain away the fine-tuning of the universe, but the model has to be finely tuned even more to get a universe that could support life. And you see the same thing with another model, which is called the string landscape model. And the idea is that cosmologists apply string theory to cosmology and envision that we've got these multidimensional brains that would bounce into each other and produce lots of universes, perhaps with different laws. But here again, the model only works if it's carefully fine-tuned. So for instance, these brains would have to be positioned to 1 part in 10 to the power of 60 for this to work. So again, every attempt to avoid the fine-tuning leads to models that have to be fine-tuned. It's kind of like this. Have you ever had a carpet in your room that's too large? What do you get? You get a bulge in the carpet. You don't like that bulge. So what do you want to do with that bulge? You want to slam it down. But what happens to the bulge after you slam it down? It disappears someplace else. In the same way, every attempt to rationalize away the fact that our universe is fine-tuned for life always goes back to theories that still have to be fine-tuned for it to work. For the fine-tuning, the evidence of design is inescapable. Now, what I'm going to do now, I know here's a couple books on the Fortunate Universe that goes into this. And the return to God hypothesis by Stephen Meyer, I was very much helping with this book. I'll go through this in more detail. But my last section of this talk, I want to deal with the evidence of design behind our planet. Because it's not enough to have a universe that can support life, that has carbon, that has oxygen, that has stable stars. You have to have a planet that's very carefully designed for life. So for instance, you've got to have a sun that's highly stable that produces the right energy. Namely, you need mainly heat and you need visible light. You also have to have an atmosphere that allows us to breathe. So the atmosphere must have enough oxygen to give us, so our bodies can get enough energy to move, but it can't have too much oxygen because then the oxygen would erode our cells. You would decompose our cells. If you ever put like an apple core in the atmosphere for a day or two, it turns brown, right? Because the oxygen decomposes living tissue. So if there were too much oxygen in our atmosphere, it would be toxic. So our atmosphere has just the right amount of oxygen to allow us to breathe, to produce rigorous activity, but not to kill us. Also, we have to have the right atmospheric pressure. So we have nitrogen, and there's a lot more nitrogen than oxygen, and we have just the right amount of nitrogen and oxygen to produce the right atmospheric pressure. Because if the pressure were lower, we would lose lots of molecules that we would not want to lose. And if it was larger, we would lose the molecules that we do want to lose. So we don't want hydrogen to build up in our atmosphere, or else it could explode and basically burn up all of life. In addition, we have a moon, and the moon is the perfect size and the perfect distance to stabilize our tilt. Because our planet has a minor tilt, and that tilt compared to the sun is what produces seasons. If the tilt were too shallow, the equator would be too hot to live, and the poles would be too cold to live. But because we have the right tilt, we have seasons which moderate the temperature, so we've got life that lives from equator to pole. And if the tilt were too much, it would create other, which would produce would produce winds of perhaps 1,000 miles per hour that would completely eliminate our ability to produce a stable civilization. In addition, the moon produces tides, which recirculate the oxygen in the waters. So the moon is essential for us to have the amount of life on the planet that we do. Now, in addition, we have the outer planets, which are very, very large. And what these large planets do is they produce an enormous gravitational pull, so they pull asteroids away from us, and they move and they capture them in that planet. It's like a giant vacuum cleaner cleaning our solar system with all these asteroid debris. Without this planet, Earth would be bombarded by asteroids and life would not be possible. Perhaps bacteria, but that's about it. Also, our planet has a very strange property. There is magma that rotates, so you've got rotating charge that produces a magnetic field. And that magnetic field protects us from dangerous radiation from the sun. Without that magnetic field, life would not be possible in our universe. But one of the most interesting aspects is that the same molecules that allow us to breathe and to have a stable atmosphere also only allow visible light and infrared radiation through. So they block out the harmful radiation and they let the right radiation through. In addition, water has the perfect properties that it also blocks out the harmful radiation but allows light and heat to penetrate the oceans and lakes to allow photoplankton to produce oxygen. Here again, what we see is our atmosphere is beautifully designed for life, and that goes back to the fact the laws of physics were ideally designed to allow for the same conditions that allow us to breathe and have a stable atmosphere, to allow the right light to go through our atmosphere. But in addition to that, the laws of nature and our planet were not just designed to support life, but they were designed for scientific investigation and cultural advancement. So the oxygen and nitrogen in our atmosphere is not just perfect to breathe, but it produces just the right amount of fire. If we had less oxygen or too much nitrogen, then you wouldn't produce enough fire to advance technologically. But if you had too much oxygen or too little nitrogen, which acts like a fire retardant, then the fire would burn all our forests down, and be very problematic. So again, we see this convergence of a design for life and for scientific investigation and cultural advancement. Also, the atmosphere that allows us to breathe is transparent so that we can view the stars. We are also in the perfect place in the Milky Way, in our galaxy between two spiral arms, away from dust and light, so that we can view our solar system and we can view the stars and do astronomy. My favorite example, though, is with vision. What happens is the wavelength of light that corresponds to visible light is essential because that wavelength allows for things like photosynthesis and other chemical reactions. But it's also perfect for the optics of the eye. So for an eye the size of a human eye, the wavelength is ideal to produce a high resolution image shortly in back of our lens. And what would happen is if the wavelength of light were much longer, our eyes would have to be the size of football fields to have high resolution vision. What's also really amazing is that if you look at photoreceptors, they're cells that have discs with special molecules that will detect photons. Now, the discs have to be a certain size in order to detect photons efficiently to see. But it just so happens that the minimum size of the disc, which is what we have, allows for a certain resolution of vision, which perfectly matches the resolution of vision from the optics and the wavelength of light. So you're seeing a convergence of design from the laws of nature to chemistry to physics to biology that points to a creator that designed everything with us in mind. Oh, it gets even better. Water is amazing. Because water is a very simple molecule. It has one oxygen and two hydrogen, but the laws of nature were carefully designed such that water has multiple, highly unusual properties that allow for life. And it just so happens our planet has lots and lots of water, which is actually difficult to explain. So for instance, it has high specific heat, much higher than nearly any other fluid. Why is that important? Because specific heat means that water absorbs lots of heat, but the temperature doesn't change much. That's why the water on our planet creates a stable environment, because the water temperature doesn't change much and it keeps our planet within a reasonable temperature range. Also, there's water flow in the oceans, kind of a conveyor belt of streams that takes cold water from the poles and brings it to the equator, hot water from the equator and brings it to the poles, and then those currents, which result from the careful design of our planet, is what allows for stable temperatures even high up in altitude near the poles and close to the equator. That's essential for life that's so distributed to our planet. In addition, what we have is low viscosity. That's essential because when we look at when we look at the water cycle, what happens is water from oceans and lakes evaporates. It then will rain on mountains, and what water does is its low viscosity allows it to easily flow across the planet. If water had a high viscosity, in other words, it was like molasses that didn't flow very easily, then the water would be trapped in small regions of our planet, and you wouldn't have life across our planets. In addition, the low viscosity allows for blood to flow easily in your body that allows for life. If blood were like molasses, you wouldn't live very long. It would be very problematic. In addition, what you find is water has high cohesion and high adhesion. Adhesion is what causes water to stick to things. Cohesion is what causes water to stick to itself. And what's amazing is when water goes through rocks, the adhesion pulls the water through the rocks in crevices. The cohesion pulls water behind it, and then water has another remarkable property. When water freezes, it gets larger, so it breaks apart rocks, and that turns rocks into soil, which is essential for life. In addition, water dissolves many, many different substances, which allows water to dissolve minerals and other important molecules on mountains and pull them down into places like forests, so the soils are very nutrient rich. If water couldn't dissolve so many things, again, there wouldn't be life throughout the planet. In addition, the fact that water dissolves so many substances is why we can live, because the water in our body can dissolve minerals and nutrients and take it throughout all our cells. Again, another property essential for life. The low density of ice is also important because water, when it freezes, it floats, which is really unusual, and that causes ice to form on lakes, rivers, and oceans, which acts like a blanket, which keeps the temperature look high enough in these lakes and oceans so that fish can live all year round. If water froze from the bottom up, there wouldn't be life in our oceans and lakes. Finally, we've got evaporative cooling. Water absorbs an enormous amount of heat when it evaporates, very unusual, so that keeps the body temperature of living organisms at a stable temperature. If that were not the case, we could not do rigorous activity for long periods of time. So all these properties were carefully designed with life in mind. So what we see is that there is this amazing evidence of design in the laws of nature, in our planet, in water, and also designed to allow scientific investigation and cultural advancement. Why is that significant? Well, imagine that you're walking through the woods and you come across a cabin. You go in the cabin, and the cabin, you notice, has your favorite clothes in the closet that perfectly fit you. Maybe a coincidence. You then notice there's your favorite food in the refrigerator. That's nice. But then you notice there's pictures of your relatives and friends in the living room. And also there's a cell phone with your best friend's numbers programmed into it. You probably would say, what an amazing coincidence. What you would say is that somebody knew you were coming and set everything up with you in mind. In the same way, when we look at the design throughout nature, we see that God designed everything with us in mind because we were the intent of His creation. Thank you.